Hello, I am Jae-hee Lee, the head instructor of Lee's Science Academy. In our previous lecture, we created natural numbers. Today we will study the operations on natural numbers, which are used to create new natural numbers from existing ones. You are probably very familiar with how to calculate natural numbers, but here we will explain the concepts and principles of these operations. Concepts and principles are the foundation for in-depth mathematics study, so you must understand them well. Here are the main topics for today's lecture. We will define several terms, such as operation and operation rules, and as representative number operations, we will explore the four basic operations of natural numbers: addition, subtraction, multiplication, and division. Let's define a few terms. At Lee's Science Academy, an operation is defined as the process of manipulating the objects of mathematics according to defined rules to create new objects. The defined rules at this time are called operation rules. In actual calculation, this would be the calculation method. There are no specially fixed operation rules, and you can create them freely as needed. However, from a practical point of view, there are particularly useful operations, and we will learn these useful operations and rules going forward. We can perform any operation once we set the rules. But let's say we performed an operation and want to reverse it to make it invalid. What should we do? The act of making it invalid would also be an operation that creates a number using numbers. We will learn how to reverse it gradually, but for now we will simply define the operation that makes it invalid as the inverse operation to the performed operation. Please note that an inverse operation forms a pair with the executed operation. We define the entire collection of mathematical objects as a set. The collection of all natural numbers is called the set of natural numbers. As a symbol expressing the abstract concept of a natural number set, we use the letter n, taking the first letter of its English name. When it is necessary to distinguish it from the standard alphabet n, a stylized letter n is used. We will study sets in more detail in another video. The objects of mathematical operations include not only real numbers but also exponents, logarithms, sets and propositions, vectors, complex numbers, functions, derivatives and integrals, probability functions, and many more. You've probably heard all these terms at least once. If we take a real number and create a new real number according to given rules, we have performed an operation on a real number. If we manipulate a vector to create a new vector, we have performed a vector operation. We will gradually learn about these various mathematical objects as well. Today, among the various operations, we will look at the four basic operations of natural numbers, which are the fundamental and most important operations of all. The four basic operations are divided into addition, subtraction, multiplication, and division. Today, we will study these four operations specifically for natural numbers, not other numbers. The unit that is the target of the operation during an operation is called a term or operand, and operations are sometimes classified according to the number of operands involved. If there is one operand in an operation, it is a unary operation, which applies a rule to a single number to create a new one. If there are two operands, it is a binary operation, and if there are three, it is a ternary operation. The four basic operations of natural numbers are binary operations that create one number from two numbers. The negation of proposition P is not P, so it is a unary operation, and when targeting functions, differentiating a single function to create its derivative can also be considered a unary operation. Let's look at the addition operation, adding or adding to. Can you understand that an operation is also a representative abstraction process? Let's try the abstraction process of an operation. The addition operation, simply put, is the abstraction of the act of adding itself. Please focus on the word act. There are 5 apples on a plate and 4 apples separately. We perform the act of moving the apples that are outside onto the plate. This act would be the act of adding or adding to. Now all the apples are only on the plate. Let's express the numbers involved in this process. The initial number of apples on the plate is 5. The number of added apples is 4. The number of apples after moving them is 9. These numbers are not independent or unrelated. They establish a relationship through the act of moving them. Please pay attention to the word relationship here. Now let's express the relationship these numbers have using symbols. The relationship between these numbers is created by the act of moving. We can abstract the entire process and result related to this act, give the entire process the name addition, and represent the entire abstraction process with symbols. The act of adding is expressed by the plus symbol, and the result can be abstracted by the meaning that the total number of apples is the same as the number of the final product, which is expressed by the equal symbol. We can abstract all the relationships in the entire process at once and express them simply with symbols as follows. 5 plus 4 equals 9. This symbolic expression is very short, but the meaning it conveys is clear. There were 5 apples, and adding 4 apples to them made a total of 9 apples. How is it? Has the concept of addition that you have always used become a bit clearer? Imagine the act of directly moving 4 apples to a place with 5 apples to make 9 apples to verify the process. Here, even if we change apples to pairs, the expression 5 plus 4 equals 9 does not change. Why is that? As we learned in the creation of natural numbers, numbers are 100% abstract and express only the concept of numbers without distinguishing objects. Reflecting this property, we can use the exact same symbolic expression to represent the concept of numbers regardless of the object, without any distinction. Please understand that this addition operation is an act called an operation using the two numbers 5 and 4 to create a new number 9. In this way, we have abstracted the process and result of creating a relationship by the act of adding, and can express the entire act with symbols. The subtraction operation is taking away. Unlike addition, subtraction is the abstraction of the act of taking away itself. From a plate containing 9 apples, if we perform the act of taking away 4 apples, only 5 apples remain. The numbers involved in this act are expressed as follows: 9, 4, 5. This act of taking away is defined as subtraction. Now let's represent the entire process of taking away, subtraction, with an abstract symbol just like we did with addition. The abstract symbol for the act of taking away is set as minus. And just like in addition, the meaning that the number of apples obtained as a result of the act is the same as the number of the final product is abstracted and expressed with the equal symbol. Now we can abstract the entire subtraction process and express it with symbols. 9 minus 4 equals 5. This symbolic expression is also very short, but its meaning is clear. There were 9 apples, and taking away 4 apples left 5 apples. You can understand that the result of the subtraction operation also created a new number 5 using 9 and 4. Since subtraction, like addition, is an operation on abstract numbers, it does not distinguish objects and expresses only the concept of numbers, so you can understand that the exact same symbolic expression can be used regardless of the object. Having defined addition and subtraction, let's look at the relationship between them. To state the conclusion first, subtraction is the inverse operation of addition. Addition is the operation of adding to an object, and subtraction is the opposite operation of taking away. In reality, to invalidate what has been added, you must take it away. To reverse an addition, you must perform subtraction. Subtraction is the act of reversing addition, making it the inverse operation of addition. It reverses the previously performed act of adding, making it as if it never happened. An inverse operation reverses a previously performed operation to make it invalid, so it presupposes that an operation is performed first, and the reversing operation is applied to the operation performed at that time. The performed operation and the reversing operation form a pair. First, we perform the addition operation of adding 4 to 5. To reverse this operation and obtain the initial number 5, we perform the inverse operation of taking away what was added, so by taking away 4 from 9, we obtain 5. You understand, right? Please thoroughly understand that subtraction is the inverse operation of addition. This time, let's look at the multiplication operation. Multiplication is the abstraction of the entire act of repeatedly adding the same number to create a new number. Multiplication is the repeated addition of the same number. Please keep this meaning of repeated addition of the same number in mind. As shown in the picture, to the plate with 3 apples from the pile of 12 apples, if we perform the act of moving 2 apples 6 consecutive times, 15 apples will be placed on the plate. If we express this as an addition operation, it becomes 3 plus 2 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 equals 15. Doesn't the expression of adding 2 6 times look a bit inconvenient? Mathematicians figured out that the numbers involved in the act are the number being added, 2, and the number of repetitions, 6, and created a new simple symbolic notation. As an abstract symbol expressing this repeated addition, a different symbol from addition is used, and it is read as multiplied by or times. The notation for repeated addition is simply expressed as number to add multiplied by the number of repetitions equals total number, and the operation according to this notation is defined as the multiplication operation. The operation of adding 2 6 times can be expressed by applying the multiplication operation as 2 times 6 equals 12, and the entire process can be symbolically represented as follows. If you add the multiplied number 2 times 6 to the given number 3, the result equals the number 15. How is it? Do you have a new understanding of the concept of multiplication that you have been using mechanically until now? Since multiplication is fundamentally repeated addition, if you take the time to calculate it calmly, you will eventually find the value, but to find the value quickly, we memorized the multiplication tables. The final basic operation is division. If multiplication is repeatedly adding the same number, division expresses the act of creating a new number by repeatedly taking away the same number. Therefore, division becomes the inverse operation of multiplication. I just told you the conclusion directly, but do you understand? Addition is the act of adding, and subtraction is the act of reversing the addition, so subtraction was the inverse of addition. Since multiplication is defined as the act of repeatedly adding, and division is defined as the act of repeatedly taking away, division becomes the inverse operation of multiplication. It is a natural understanding based on the definition. To abstract and notate the act of repeatedly taking away, we use the division symbol to express the concept of the act of repeatedly taking away, and we define the name of such an operation as division. The notation is defined as given number divided by the number of repeated removals equals the number removed at once. Let's look specifically at how the act of dividing proceeds. Let's bring in what we calculated earlier in the multiplication operation. We repeatedly added 2 6 times to make 2 times 6 equals 12. From this result, we will repeatedly take away the same number 6 times. Then one bundle to take away will be 2. If we denote the entire action process with symbols, we divide the given number 12 by the number of repeated removals, 6, to get the number removed at once, 2. You should be able to read the meaning by looking at this formula. It means that if you take away the given 12 items 2 at a time for 6 times, you can remove them all. At this time, the divided number 12 is called the dividend, the repeating number 6 is called the dividing number or divisor, and the unit number taken away, 2, is called the quotient. Just as subtraction was the inverse of addition, division invalidates the repeatedly added multiplication by repeatedly subtracting it, so we can see that division is the inverse operation of multiplication. So far we have explored the concepts expressed by the 4 basic operations and their rules as operations of natural numbers. According to the operation rules and the definition of inverse operations, we also understood that subtraction is the inverse of addition and division is the inverse of multiplication. In the next class, we will learn about the closure property of natural number operations within the set of natural numbers. This concludes today's lecture. Thank you.